Hi grade 7s, in this lesson of 2D shapes we're going to look at the properties of quadrilaterals. So quadrilaterals are four-sided polygons, and we know from our previous lesson that a polygon is a closed shape with straight sides. So we look at a couple of polygons in this lesson, and the interesting ones are a trapezium, a parallelogram, a rectangle, a rhombus, a square and a kite. And these shapes, we call them special quadrilaterals because they have certain properties that we want to look more into. And we're also going to notice that later on these properties help us calculate certain things about these shapes. And it's used quite a lot in maths in the next couple of years. So it's a very good idea for you to learn these properties because you're going to, like I said, use them every year until you get to matric. And by the time you get to grade 10, you're going to be using them in interesting sections like analytical geometry and Euclidean geometry, normal geometry. So when we started constructions, we talked about properties of lines, well, the relationship that lines have with each other. So if lines never touch and they stay the same distance apart, like these lines, we call them parallel lines. And if lines meet at a right angle at 90 degrees, we call them perpendicular. So the first property of special quads that we want to look at is which of them have got parallel sides. So we don't say lines anymore, we now call them sides. And you'll notice that in this first one, we all know this is a square. If you don't know, this one is a rhombus, this is a rectangle, and this is a parallelogram. And the last one, this is called a trapezium. So we're just going to layer these properties of special quads on. As we go along, we're going to build this picture up a little bit. The next thing we look at in special quads is which of their sides have got equal lengths. So in a square, you can see all four sides have got equal lengths. In a rhombus, all four sides have got equal lengths. In a rectangle, opposite sides have equal lengths. In a parallelogram, opposite sides have equal lengths. And in a trapezium, there are no sides that need to have the same length. In a kite, adjacent sides, so the difference between opposite, those are opposite, and these are adjacent, as in the ones next to each other have got the same length sides. So you'll also notice that all the way around the sides aren't the same. So these sides aren't the same, but two pairs of adjacent sides are the same. Then we're going to look at the other important property is which shapes have got right angles. So having a right angle in a quadrilateral means that it's a regular shape for this shape over here. Because remember our definition of a regular shape, it must have equal length sides and it must have equal size angles. So the only way for a shape that has 360 degrees on the inside of it to have equal size angles is for them to each be 90 degrees. So this shape has got 90 degree angles. This side has got 90 degree angles, but is it regular? No, it's not regular because these opposite sides are, well, only opposite pairs are equal, but not all four sides are equal length. And then this shape over here, it has equal sides, but you'll notice it doesn't have right angles, so this can't be a regular shape either. And then this parallelogram does not have right angles, neither does, well, this one can, but it doesn't have to, and this one also can, but it doesn't have to. Okay, and then our final picture is when we've got all of their angles placed in. So everything in this diagram is the significant properties of these special quads. I haven't included at this stage the diagonal, so diagonal would go from corner to corner of a shape. I'm sure you know that already. But we'll leave that for grade 8 to discuss diagonals. For now, if you can remember which shapes have got equal sides, which shapes have got opposite pairs of equal sides, which shapes have got opposite pairs of parallel sides, which shapes have got right angles, and which shapes have got opposite pairs of matching angles. So that's also important in these shapes here. They're not all 90, but they do have opposite matching pairs of angles. So this helps us with all sorts of calculations later on. And then the kite has got two important properties that we look at. The kite has got two pairs of adjacent sides that are equal. It also has, between the non-equal adjacent sides, so this side and that side, it's got equal angles that form. So there's an angle that matches that angle on this side. And then this poor little trapezium has got only one property. The only property it needs to have is one pair of parallel sides. It doesn't need to follow any other rules for it to be a trapezium. And then lastly, I've just put the names on them. So I would recommend that you redraw this on a poster for yourself. It's not for marks, but just redraw it and commit these facts of these shapes, these properties of these shapes to memory, because you're going to use them over and over. And if you learn them now, then you're going to save yourself some work further down the line. One last thing I wanted to show you is that a kite can look either like this, a normal standard kite, or like this. I'm sure you've flown both types of kites before, but this has the same properties as this kite over here. Now the exercise that goes with this set of work, with these notes, is a little bit more challenging than the others. It's asking you to apply these facts that we've discussed. So I think that once you've made that poster, it's going to be easier for you to answer these questions. This question says identify each of these quadrilaterals. So they only give you the properties, and then you must look back at the properties and see which properties fit in with which shape. So this is a rhombus, this is a rectangle because of the right angle, this is our trapezium that only has one property, this is a kite because of these adjacent sides that are equal, this is a parallelogram because all that you need for parallelogram is opposite sides parallel, and then this is a square because equal sides and a right angle. Then if you go through this table, try it on your own, and if you can't manage, have a look at my answers. Otherwise, if you have managed, mark your answers against mine. Onto these questions at the bottom here, it says which quadrilateral is a regular polygon? So the only quad that has equal sides and matching angles or equal angles is a square. In what way is a trapezium like a parallelogram? A trapezium only has one pair of opposite sides parallel, so parallelogram has two, but at least they have one pair in common. In what way is a rectangle like a parallelogram? It's alike in two ways. It has two pairs of opposite sides parallel. It also has two pairs of opposite sides equal. How does a rectangle differ from a parallelogram? Well, a rectangle has interior angles of 90 degrees. A parallelogram, this one over here, it only has opposite sides or opposite angles of equal size, but they are not all 90 degrees. That would make it. So actually a rectangle is a specialized parallelogram. There are a few shapes that become more specialized and turn into other shapes. But if you learn their properties as a start, then it'll get you through this exercise. What property does a square have that a rhombus doesn't have? A square has interior angles of 90 degrees, and a rhombus, you can see it has all the same properties as a square, except for that I always call a rhombus a squished square. So it's slanted over to the side. Okay, in what way is a square different from a rectangle? Well, remember the rectangle is like an elongated square. So a square has sides of equal length. In what way is a kite like a square? So that's quite tricky. A kite only has two pairs of adjacent sides equal, but not all sides are equal. So you could have said that, or you could say they're both quadrilaterals. And then I said we're going to keep this diagonals information until grade 8, but you can learn that if you wanted to. The diagonals of a square and of a kite intersect. In other words, they cross over at 90 degrees. And then how does a kite differ from a square? Kites have no pairs of parallel sides. Squares have two pairs. Kites have one equal adjacent pair of sides. and squares have all four sides equal. So this should say two pairs of adjacent equal sides, but I think you can look at the picture and see what I mean. In what way is a kite like a trapezium? So none, because the one has got matching sides and the other one has got one pair of parallel sides, so they're very different. What is the difference between a kite and trapezium? That's a nicer question. A trapezium does not need to have any equal sides, whereas a kite does not have any parallel sides. What is the difference between a rhombus and a parallelogram? A rhombus has four equal length sides. And in what way is a rectangle like a square? They both have interior angles of 90 degrees. So to summarize this question, these answers I've done in purple here are the more important questions. These questions are quite tricky, but the ones I would like you to know for tests and that are question 4 and 5. So see if you can answer those on your own and have a look at the memo if you're stuck.